he will do the methodology of detailed apportioning of, let us say, in a metro. So before that, I thought some background we will introduce so that you are ready for that. Now, what is this talks about is, you have it with you? Yeah, that's one. If you have n systems, the overall reliability or availability is given to you. Availability, let us say in this case it is availability, yeah, reliability, sorry. The overall reliability is given to you, and there are n systems. Yesterday you saw Mr. Paul was drawing a block diagram, signaling, loco, this, all have to work in series. So first level, sorry. The first level is so 1 to n. So this is R1, R2, Rn. The overall is given to you, some figure is given, let us say 99.9, sorry, 99.9%. Yes, maybe SNT, remember we did a problem also, 75% goes there, 35%, that was an assumption. So if the overall is given, so obviously R1, R2, R3, Rn will be equal to 0.99. Now this has got any number of solutions, is it not? It is not one solution, because so many variables and the product has to give. So any number of, infinite number of solutions I can bring out to this, to solve this equation. Then how do I apportion it? So one method, the first, after all everything, in this kind of problems it is a lot of approximation. So one method is you apportion for each of them equally first. To start with, let us give equal. Everybody gets only equal this thing. So then what happens? So this will be r to the power of n will be equal to 0.99. Is it not? So n is known, how many fellows are there, how many subsystems are there. So you make, from this you find out what will be the r, individual r. Each one become equal to r, equal. So r to the power n equal to this thing. So I can find out r and say individually, this is your reliability, this is your reliability, this is your reliability. But this is very, very approximate, very approximate. There is nothing big in this. So a lot of people have made some work on calculations of all these things, reliability design. Yesterday I think he showed also agree method. The problem is an agree method. What you given is agree method. So in this method, what they do, you divide, instead of this thing, you do the reliability depending on the complexity of the system. Okay, suppose in this, I have here 3 subsystems, I have 4 subsystems, and this fellow has got some 10 subsystems. You apportion in the ratio of how many subsystems each fellow has got. If he has got if let us say signal has got 4 subsystems, then there is a 4, his is 4, and what the total number of subsystems are, you add all these things. You add all the subsystems. So in this ratio, you do it. If signal has got m subsystem, the total number of subsystem is n. You do it in m by n. Instead of equal R1 into R2 into R3. So that is what is given here. So if the overall is R star is given, so the unreliability, because we work on unreliability domain, equal to m by n. You know the total subsystems available in the metro, the entire whole thing. How signals have got how many subsystems?